Perfect. Hi, everyone. So I'm Maria. I'm the co-founder and CMO of iris.ai. So if you allow me, put the next slide. So let's start from here. So many of you probably already know what a blockchain is, but just in case there are some who don't, let's take a step back and discuss the basics before we go and discuss science and blockchain. So blockchain is a technology that allows the world's first decentralized and transparent database. So this database can be reliably maintained by anyone who wants to do that without the need to know the other maintainers. Now, this technique can, for example, remove an intermediary, that is a bank or a publishing house. And in the case of the bank, the money moves directly from the transferor to the recipient. Now, virtual currencies like Bitcoin already, of course, work, but that's really just the beginning, and that's what we're gonna discuss today. So, one of the blockchain, one block of a blockchain can be compared to an account book that records all events over a certain period of time. Now, when transactions such as transfers have been booked and the account book is closed, it can be linked to earlier financial books. Now, this creates a complete chain of account books maintained by all who wish to do so. And so those books are incorruptible and can also be programmed to record virtually everything of value. And of course, my phone is ringing at this point, so I'm going to close that. Sorry about it. So that's just like what blockchain is in brief. So if you go to the next slide, how it actually works, here's an image of that. So first, a user requests a transaction, which is then broadcast to a P2P network consisting of computers known as nodes, as we know. The network then validates the transaction and the user status. Now, the verified transaction can be literally anything of value from cryptocurrency to contracts or other information. And after the verification process is successfully completed, the transaction is combined with others to create a new block of data for the ledger. So finally, a new block is added to the existing blockchain, and that is permanent and unalterable. So with this brief introduction, going to the next slide, it's really great, but the core question really is how that can help the world of science. So that's what we've been spending our past 9 or 10 months at iris.ai, really figuring out the core, first of all, the core problems of science, and then figuring out how blockchain and AI can help us to solve those problems. So Ami, if you go to the next slide, here are the issues. So world runs on science, right? But there's an information overload, too much knowledge that we humans, there's just like so much knowledge that we humans cannot tap into because our brains cannot just like read and understand all the huge quantities of data that is out there. There are built-in biases in the citation system benefiting certain researchers and their affiliations. There's a massive problem with reproducibility, also known as the file drawer effect, which is about mounting evidence, indicating that the science itself has become biased towards certain types and certain kinds of findings, like novel, attention-grabbing, but ultimately unreliable. Now, the incentives to produce positive results are so great that some scientists are simply locking away their inconvenient data. Then there is, of course, access issues, as the highly lucrative publishing industry is locking papers behind the paywalls. And then finally, the careers of scientists are set to be hijacked by perverse incentives. The scientists should be pursuing the best questions and uncovering meaningful truths, and instead they're actually forced to prioritize self-preservation. So a number of issues. If you go to the next slide, at iris.ai, so we're a company that was actually established 3 years ago at Singularity University. We set ourselves to fix some of these issues that the science is facing. And if you go to the next slide, we specifically focused on information overload and built-in biases. But we didn't do that via blockchain, but basically using AI, building research tools for researchers so that they can tap into the existing knowledge much, much better and more efficiently. So if you go to the next slide, just a few quick words about iris.ai. So our tools allow the users to conduct the literature review effectively without the fear of basically missing out information. and without biases. Now, the next slide just shows one of our tools, which is the exploration tool, that allows the person, the user, to put in a research question to our tool and then navigate the research landscape by building maps and navigating the maps and finding the related knowledge. And then we have the focus tool, which is this next slide, which is then focused on narrowing down the relevant data from thousands of research papers. So you can like narrow down to find really the core knowledge that you should spend time on reading. Without going further in detail into iris.ai, what I wanted to say is that, yeah, these tools are really great, but the problem is that they're not enough. Selling B2B software isn't going to fix all of these issues that the world of science is facing at this moment. And the major problems affecting academics and others wishing to access science are still there. So that's the bottom line. And and obviously those issues are related to reproducibility, incentives, and access issues. So now I'm asking if Victor wants to take it from here and explain how we're going to address those issues through Aiur.
Yeah, so hello everyone, I'm Victor, I'm the CTO of iris.ai, and I'm going to tell you a little bit more about how we initiated Project Aiur and what's the idea behind. So yeah, I mean, as Maria already said in the previous slide, there are certain issues like reproducibility issues, like access barriers, that are really problematic when it comes to other people, not scientists, and even for scientists to use the current scientific discoveries. Like a lot of companies have tried to implement scientific papers, but then what happens is that they were not able to reproduce the results, or the results were not exactly what they expected. And so then we started thinking, okay, so how should we address that? And maybe one way is to build some kind of a engine. I mean, we already have the AI that can actually read a lot of articles and indicate some notional markers of if the things are reproducible or not. So why don't we build like a knowledge validation engine? But then it comes the question about trust. So if we as a private organization build a knowledge validation engine, that means that there is a single entity that actually holds this software, the IP and everything, and it makes it much more easier, first of all, for giants like the publishing houses to shut it down, but second, also it creates like it adds more questions to the mix. I mean, if we are the right people to hold this IP, and like, could we not sway and bias the system and so forth? So that's why we were thinking, okay, so that should be more of a community effort, something that is owned by the researchers themselves. Because I mean, at the end of the day, that is what science is about truth, validity, results, and things that could be reproduced and owned by everyone. So then we were thinking, okay, so then we need this ecosystem that owns the knowledge validation engine also to provide the quality for the research articles. So that's where this whole new incentive models come from. So the real value added to the system comes from actually validating the knowledge. So we need to incentivize people that want to help training the knowledge validation engine, but also standing on top and like adding additional value by reviewing the articles, something that the current review process doesn't do. So the reviewers actually are not getting paid for actually reviewing the articles, and the margin, like the value captured from publishing the article until the end user, is captured by the publishing houses, which we think should not be the case. It actually should return back to those that actually provide the quality assessment, which is the reviewers. So that's how we thought about Project Aiur, introducing new incentive model where like both authors, reviewers, and all people involved in the process of building tools for those people so that they can do the proper quality assessment of the knowledge can participate in one ecosystem. And also adding the knowledge validation engine as the core tool mechanism. I mean, something that we know something about and we want to introduce, and we want other people to participate and develop with us. And finally, having a validated repository of knowledge where all the articles kind of that have gone through the knowledge validation engine, have passed certain criteria, certain peer reviews done, and so forth, are published in one place so everyone can read them. But if a particular institution wants to kind of implement this and go further into more details, they'll have to pay for the report that is generated from the knowledge validation engine. So I think that's kind of the main concept. I mean, later on we can go into the Q&A and you can ask more questions about it, of course. But we can go now to the next slide. I'll go into more details into those components. So a few more words about the incentive model. So we envision at the beginning like about 5 categories of people that or of users that can earn tokens. So those are like AI trainers, people that annotate text, annotate documents, select keywords, select other features, and help the machine actually learn what's the important bits and pieces of a scientific article, coders that actually produce the code for the knowledge validation engine, quality assurance people that test and provide different audits, even security audits maybe at some point. And of course, the scientists, like people that publish research and people that do peer review. On the other side of things, we have how the tokens can be used. And we have spending tokens on, for example, third-party providers like iris.ai who will build tools on top of the knowledge validation engine. So at the beginning, we'll provide direct access to our current premium tools. Of course, people will be able to directly call the Aiur engine, the knowledge validation engine, for their own purposes with the tokens, and any other third-party providers that want to build applications on top. I mean, this could be used also for patents, for patent authorities that check if the patents are correct, for legal purposes, or for any other purposes. So we would not be, hopefully, the only ones that work with the knowledge validation engine. I think it can be used in many areas. So yeah, we can move forward to the next slide. So the knowledge validation engine in itself, the idea is that you enter into the engine like the document that you want to validate, or a hypothesis or a report, like in any form. So what the engine will do, so we have been working like for a couple of years in NLP, and right now one of the hot topics is hypothesis extraction and argument mining. So the idea is that the knowledge validation engine will extract hypotheses from the text, will match these hypotheses to hypotheses in other documents, will also identify what are the building blocks in this article, meaning things that are kind of mentioned in that article that are important for the hypothesis but are not proven in that particular article. So you need to read those as well in order to be sure that what this hypothesis is saying is true. So it will build you kind of a tree of documents that, or like pieces of documents that you need to go through if you want to fully assure yourself that the hypothesis is true. Afterwards, it will also check for other hypotheses that are assuring this hypothesis or contradicting this hypothesis. So at the end of the day, it will produce a report on the whole tree of documents, and tells you what is the trust level of this article based on what people approved and disapproved along the branches of the building blocks, and also produce your reproducibility score based on how the methods have been evaluated, what results are there, and if the data for those results is available, and also if the data and the experiments match the hypothesis claims, more or less. So this is what we envision. So you provide a text, it could be a paper, hypothesis, or report, and you get at the end a report on basically 2 scores, trust level and reproducibility level, with the details of why that score is for the trust level and why is that score for the reproducibility level. All right, so yeah, I can talk like quite long on that, but let's move forward. So on the validated repository, so yeah, I mean, we envision here to capture all of the articles that actually have passed the knowledge validation engine, plus a couple of other restrictions, like besides the knowledge validation engine, it should also pass like at least 10 peer reviews from other peers that should not contradict with the knowledge validation engine. If they do, then the peer reviewer should submit an appeal and tell that the knowledge validation engine was wrong. So in this way, we ensure that there the claims are always valid. Furthermore, we will start the validated repository also with giving possibility for people to submit what we call like failed results, or basically when you do research, sometimes you try an alternative method and you're not able to beat the state of the art, but that doesn't mean that your research up to that point is not valuable. I mean, that means that if we actually publish this result, there are two options. Either people would not start and do this alternative method again, which has happened quite sometimes in the history of research, that people have tried the same alternative method several times because it just hasn't been reported that is not able to beat the state of the art. And then, or the second point is that maybe there is something that is missing today for using this alternative method that will come out later, and then people will be able to make the connection later using those results. So we'll kind of provide the possibility for researchers to submit this kind of reports. It will also allow like parallel publishing, so you can publish your work on some other places as well. We won't be exclusive just for our repository. The content will be open access, so anyone can read the articles themselves that are published, but the reports from the knowledge validation engine will be paid, so people will be getting rewards if somebody is trying to re-implement their articles and so forth. Also, the whole idea of the knowledge validated repository and the knowledge validation engine is that it provides a very quick way of reassessing. So every time someone is using the knowledge validation engine and your article, let's say, appears on the tree, on the true tree of his article, there is a chance for reassessing your article too. So then there'll be an ongoing review all the time, every time your article appears as a result. And people may challenge that in the future. So it's not going to be just one-time review as it is right now. It will be an ongoing review throughout the whole living process of your article, basically. So if that article appears as a baseline article for some other article, then it will be peer-reviewed as well. Which makes it much more rigorous towards higher quality research. Okay, so moving forward. Yes, I think here I will actually give the word to Jacobo. Hey, he can explain you some more about why exactly blockchain and why do we need a new token.
Hello, hello. I hope the sound is working fine. I've heard everybody else perfectly so far, so hopefully we'll keep it that way. On dual question on this slide, why blockchain and why a token, a new token? On the blockchain front, we feel that to solve the issues that we are trying to solve, the blockchain is the best possible technological tool to help us do that. And we think that on several levels. We think that's on the level of trust, and Victor has touched on that before. Today, the system of science places a great deal of trust on a number of intermediaries, namely the publishing houses, and their processes in terms of selecting what's worthy of publishing, what's not, and a number of calls that they make that we think come loaded with biases that are obviously, they're often less visible, but quite prejudicial to the future advancements of science as we see it. So there's the trust issue, there's the quality issue. We also believe that the degree to which this peer review process, to name a critical part of the whole scientific process, is done today doesn't set us on the right path to achieve the maximum levels of quality at the end of the journey. We believe that the blockchain, with its ability, this untampered ability, or the ability to be untampered, is a fantastic technology to help build a system where things can be challenged more effectively. Today, there's the reviewer, there's the submitting author, and the double-blinded review, or whatever mechanism has been put in place by the publishing house of the relevant journal. And that's just about it. It's quite hard for the public or another scientist to go and challenge and have a say in the assessment of the validity or some issues that might arise in connection with that specific paper. So from that viewpoint, allowing for direct anonymous or pseudo-anonymous challenge of that review process, we also believe that we're on the path to better quality results, and the blockchain is really useful in helping us achieve that. And on the left side, on the economic model, the whole thing around decentralization that is enabled by the blockchain also creates a powerful tool to create new incentives. And again, I think Victor and Maria have touched on that. The ability to generate tokens for value-added contributions to refining these algorithms and creating this knowledge validation engine. The fact that to date, those publishers have that central position in the system and can, censorship to a certain extent and bias what is considered to be the state of the art, we believe falls away, or at least is significantly eroded once you introduce blockchain technology in the system and you have neutral miners somehow preserving this repository of data. People who do not have a direct, they cannot be easily punished by a central publisher or by an established publisher in terms of wanting to influence their behavior of maintaining these data sets. That is another area where we're very excited about the blockchain being the right tool to help us address the problems that Maria ran through earlier on. Then the second part of the question, well, why a new token? I mean, you got Ether, you got Bitcoin, you got so many tokens today. Why do you really need to coin a new one? Well, the answer for us came as we realized that we were trying to establish an uncertain two-sided marketplace. We believe in the power of the incentives that we can build in Project Aiur around these blockchain developments, but there's huge uncertainty at both ends, on the supply side of tokens and the demand side of tokens. In what sense? Well, in the sense that sitting here today, we find it impossible to put a price in fiat currency, in dollars or in euro, in terms of what should it be worth to annotate a scientific paper and provide an annotated set to train algorithms to help us build this engine. We're just too far off from being able to economically put a fixed price on that. But it's not just on the supply side of tokens or how to generate tokens. It's also on the demand side of things, where, to price to what extent a third party interested in tapping into the knowledge validation engine is going to pay, or is going to be willing to pay for, API queries. So, submitting an input text and asking the engine what's to know about this paper. Is it reproducible? What are its weak spots? To price that at the other end is also, quite literally impossible where we sit today. And hence, the coining of a new token, a new crypto token, will enable us, we hope, manage and have the two sides of the equation of the token economy find its balance as we progress and move forward to really try to get that healthy economy in place where incentives are better aligned. On the next slide, when we focus on governance and this intersection of blockchain as a technology to help make better science, for us it was absolutely obvious that it was not about replacing trusting, any old publisher, Wiley, Elsevier, any of them, with trust in iris.ai or any other technology startup newcomer. It's about putting the community at the center of the ownership structure. And hence we've implemented a number of features they can all be checked in our white paper in terms of ownership caps and, a large percentage of the funds being legally owned by the community, and establishing voting mechanisms where, we are going to have a capped voting stake just like anybody else, like any other community participant. Because if we are trying to create a machine that can enable or can help us discern as a society what's true versus what's not true, it is very clear to us that that should not be under typical corporate structures. It should be under a novel way to think about governance and ownership structures that the blockchain enables and has been pretty hard or impossible to achieve to date. Next, we have the point about value and long-term value. And for us, it's incredibly important to highlight that as we try to deploy blockchain to help it sort out some of the issues that we detect are being faced today by the world of science, that this is a long-term play. This is not about, buying at 1 and selling at 2, in 24 hours, far from that. What we've built is a utility token. What we're trying to experiment with is supply flows, matching demand flows in a healthy, balanced way, where there's going to be no incentive for hodling or just hanging on to those tokens, and taking a speculative position on, trying to help or trying to see the value of those tokens rise just by sitting on them. We try to incentivize behaviors where those tokens are actually deployed using the systems and helping improve those systems. And that's, it's of the utmost importance in understanding what we're up to with Project Aiur. Now, having said that this is not an instrument adequate for kind of financial speculation or just buying and holding, we do see that there is a thesis for value accretion over time. If I own today a token, an Aiur token, as soon as we close our sale, and that token enables me to ping a bunch of algorithms, a pseudo or a proto, an MVP of a knowledge validation engine, trying to get some answers from that, we're absolutely persuaded that the quality of the answers that you as a user are going to get from querying the system in, say, 2020 is going to be superior than what it can be today in 2018. And this just by virtue of what AI developments look like. By trying to create intelligent machines that give us answers to complex questions, the constant kind of development loop in perfecting those algorithms that are the basis for the answers that the users are going to get is going to get better. We've seen it get better since our first version of our product released in January 2016 to date, and we have every reason to believe that it's going to continue getting better over time. The next slide is just a pic of the team that we took recently in Sofia, where we had a full team get together. We have a team of up to 17 people working on the project right now, full time. And on top of that, we have a collection of pretty brilliant advisors that are helping us think through the more complex issues around the project on all relevant aspects: blockchain technology, AI technology, entrepreneurship, design thinking, connections with universities. We keep working on making that the best possible list to help us get to the desired place, but we're quite happy with the shape it's taking over the past few months. And lastly, just a brief word on, as an entity that is betting on community ownership and community development of Aiur, we do not aspire to become this huge central player in the ecosystem. We are open to collaborations with just about everybody else who shares this, I'd call it a passion really, of leveraging this blockchain potential for the advancement of science. And we find companies that are trying to do things that have some connection points with what we're trying to do. We've named here a few of them. I guess there's of differences between what they're trying to do, what we're trying to do. They put a lot more emphasis on two aspects that for us are not that crucial, i.e. the hardcore publishing process, the going straight for, hey, don't publish in this traditional journal, publishing my new crypto journal, a journal where blockchain technology plays an important role. We're less keen on thinking about how to grow the project in that way, because we believe it's a bit of the chicken and egg problem. We think that providing the tech tools to help people get intelligent answers from relevant questions is the right way to build the critical mass and the token economy of supply and demand flows to really get something going, where at the end of middle of the road, it will become a natural consequence to try to publish in this platform, in the Aiur platform, as you are doing other things and gathering other value from the platform So the algorithms and the knowledge validation engine that we will be building, we think that's the right sequence to grow going forward. And some of these projects that we've come across, they don't quite see it that way. They're more into the publishing process, very short term. The other thing is that they're very focused on the allocation of funding for research. When you go through all their white papers and their thinking and you talk to their founders, that is a very specific problem they try to address, how public authorities and research funding authorities should have better tools to make those allocations, and without taking anything away from that problem, which is an important one and one that needs to be fixed. For us, it's more about channeling a lot of the money that is being spent in the R&D world today into the ecosystem. That's the supply of tokens side of things. If you are a large organization with a large R&D department, and the breakthroughs from that R&D department are critical to your perceived future success, we want to make Aiur the platform where you think you can drive some real efficiencies, bypassing the limitations that those researchers see today and face today in trying to come up with a mapping study of all relevant literature on this specific topic. That is the other key difference that I would highlight. Apart from the fact that we have shipped software products for 3 years now. We've shipped 4 full versions, and we have both feet on the ground in terms of the difficulty of getting those deployments, those future deployments that are gonna enable Aiur, and it's just something that we, and Victor especially, obsess about, putting in place the best possible software development and project management processes to really be able to deliver what we are set out to deliver. That would be the other difference that I would highlight. And that's really what we had in terms of slides of how we think about blockchain science and the different angles around that. So it's over to Ami now to, I guess, open it up for questions.
Yeah, I'll just throw up our unofficial iris.ai slogan there, stolen from The Martian. But yeah, so that was a lot of content to cover over the last over half an hour. And so I want to make sure that we have ample time to address any questions that you guys have. Of course, we're here to answer questions about Project Aiur, but in general, if you have questions about blockchain as it applies to science, we are definitely open to addressing those as well. So either drop it in the chat, I'll see it there, and then I can relay it to the team, or you can just click on your mic and say it out loud if you feel brave. So yeah, I'll give it a few minutes and see if any questions come in. I like it when there's cameras and I can see people typing. All right, so wanting to hear a bit more about the knowledge validation engine, any elements in particular? Or Victor, do you just want to go in and tell us everything else that you have to say about the knowledge validation engine?
Well, so it's a very broad topic, but of course, I mean, if you have any particular questions, I'll be happy to address those directly. Maybe I can say a few more general words. Of course, it's really hard to explain that in details, even in the white paper. Like we have, I think, only a couple of pages, but it's a really, I'll say, well, difficult to some extent, but it's also very broad topic. Like there are several software components that need to be in place. So, for example, as we described it in the white paper, it's essentially split into 4 sub-projects. So one is a hypothesis extraction engine. The other one is knowledge tree builder. Then we have reproducibility engine and validity engine. So all those 4 projects are fairly extensive. I mean, in the last few maybe a few years, a year and a half, we have been working on the hypothesis extraction algorithms together with several universities. So the idea there of that project is to be able to identify the language that kind of describes the hypothesis within the article, then identify kind of components that are related to the problem area, components that are related to the solution area, components related to the evaluation metrics and to the results, and make a causality relation between those components and the hypothesis to be able to build kind of a very, I would say, simple and smaller in terms of encoding information format. So you have kind of the hypothesis and you have like a graph structure that links that hypothesis to different fragments of the text that describe the problems, their sub-problems, then which of these problems and sub-problems are related to the solution, in what way, and how is the solution evaluated, what are the evaluation metrics, and what are the results and through which evaluation metric are they generated. So you essentially build a kind of a graph representation that you can navigate later and fetch additional content to that. So that's what we have been working on a lot. So we know a lot about hypothesis extraction and argument mining in general. So that is kind of the first step. We envision kind of enriching that in the second step with the knowledge tree building, kind of by fetching additional resources to further describe like the problem area, further describe the solution area, kind of compare with different evaluation metrics and so forth. So I see there's something additional coming in. Okay, so are you building a knowledge graph from scientific entities in research articles? So, well, you can, I mean, people, when they call stuff entities, it's really hard to, yeah, I mean, it's very broad term and a lot of people understand different stuff, but yeah, you can call it like that. So yes, we identify fragments in the text and we mark them as, let's say, problem related to problem 1 or related to sub-problem 2 and stuff like that. So yes, you can call it scientific entities to some extent, but we let the engine itself kind of define what is an important entity in the, well, it builds the graph structure. So we don't have a predefined taxonomy of entities or something like that. What NLP techniques are you looking into? So our models are mainly neural network based, but we use as a ground base for the neural network models like word embeddings and topic modeling results. So those are usually the two things as we do as a prerequisite. And then after that, based on those, we build in forward. Of course, we have some classifiers at the end that can, so the neural networks are used to find the components, and then we have classifiers that classify them into the separate groups. So yeah, I mean, it's a fairly complicated model, but it starts from word embeddings and topic models. Then on top, we use neural network models to filter out the information that is not particularly needed for hypothesis extraction. And finally, we have certain classifiers, or I would call it like more as sequence learners, that put basically those things in causal relations. Yeah, maybe I'll just finish with a few words about the knowledge tree builder. So yeah, so the idea is after you have the hypothesis extraction, the graph structure, for each and every kind of area, like the problem, solution, and evaluation, to kind of fetch additional information from other articles in order to kind of broaden the perspective of what the problem is, to see, is this hypothesis like narrow? Is it part of a bigger group of hypotheses? Is it maybe too broad and it's trying actually to, in the evaluation or solution, present a solution to a more narrower hypothesis and so forth. So do some cross-validation there. And then in the reproducibility is a little bit, I would say, different angle of things. So then it's focusing more on the evaluation metrics and basically validating, okay, so is this experiment actually reproducible? Is the data available? Are the facilities or like the environment in which those experiments are done very well described? Also, it goes into, if this experiment in this environment is successful, is it covering the full claims in the hypothesis? Are there like omitted constraints or assumptions? Because in many cases, what we have seen, especially working with some companies in the pharma industry, is that when people describe certain processes, they tend to omit sometimes important information like temperature boundaries or other environmental properties. So what we're trying to do is fetch additional information in order to make sure that nothing is omitted. So if certain process is described, but there's no information about, let's say, at what temperatures it actually should be conducted, that we can actually find that in other literature and say, yes, I mean, your hypothesis is correct, but only within these boundaries and not in the general sense. So that will lower the reproducibility score for that article because it didn't describe correctly that this is a much narrower case than what is presented. So that's one of the ideas around the reproducibility engine. It's more or less work in parallel, so it's slightly different from the other three. And finally, the validity engine is more about after building the hypothesis and the hypothesis tree to see how different researchers more or less approach these problems, and if the building blocks going to their solutions actually align to some extent. So trying to see, okay, so do people kind of consolidate their opinion about certain hypotheses? Do they, up to which level they consolidate? Because I mean, after you have like one hypothesis and it's kind of based on, let's say, 10 others, is the consolidated level at maybe 4 hypotheses are consolidatedly considered as true and the other 6 are yet to be defined? I mean, at what level of development is this particular hypothesis, and are there contradictory evidence and so forth? And the idea is not to really put a finger and say, oh, okay, so the trust level is 50% or 60%. It's more or less to show, okay, so this is the tree. Here are things that scientists agree on. Here are things that they contradict on. And this is how they contradict, so that people can actually go and see and they can say, oh, okay, actually I do support this area. So for me, this is a valid opinion. And but some can say, oh, no, I actually support this other opinion. So for me, that's not that valid and so forth. So it's more about generating a report that will help the user build a picture of what is valid and what is not, and not that we independently, at least not at the first couple of stages of the validity engine, will be able to say, oh, this is a super valid argument or not. So I think those are like the more detailed description of that. But as I said, I mean, it's, yeah, if we have to describe the knowledge validation engine and all its findings and state right now, it will probably take more pages than the actual white paper. But yeah, so if you have more specific questions, I'm happy to answer.
We need a whole other webinar for the KV. Okay, so yeah, if you do have any more specific, there it is. Oh, okay, just kidding, that's a private message. If you have any more specific questions, feel free to drop those in chat. While we wait to see if any other questions come in, I do want to share and kind of a frequently asked question that we get a lot. So when describing Project Aiur, there are sometimes blurred lines between what is taking place on the blockchain, what's being stored on the blockchain, and what isn't, because we also have AI components and things that are running off the blockchain. So Victor, are you able to go do a quick overview of what is blockchain and what is not for Project Aiur?
Yeah, all right. So of course, everything related to circulating of tokens and the token economy will be on the blockchain. So there's no question about that. So all reward mechanisms and everything coming to payment and so forth. When it comes to the actual execution of the knowledge validation engine, so far, I think the idea is that the code itself would not really live on the blockchain. I mean, we'll still keep encoded versions of the modifications done on the code base. So there will be a way to reproduce it from the blockchain. But the idea for that is just for trust, for ensuring trust. So if something happens and let's say some publishers come and shut us down, that the repository is not stored in one place, but it's actually hosted somewhere else. But that's just for validation purposes. So we're not really going to recreate every time the code from the blockchain and so forth. But there'll be a way to validate if the current version of the code is actually validated up to this point and living somewhere in the blockchain. The code itself, so the execution of the code so far is considered to be either hosted by people in the community or by a cloud provider. So again, it's not really going to live on the blockchain, but the execution will happen by people, members of the community. And we'll pay, so if we use cloud provider, we use cloud providers that actually take as payments crypto, so that the community can actually pay for that directly and not having like representatives that have to provide their credit card details and so forth. Further on, when it comes to the validated repository, which is probably more interesting, is we're thinking of using distributed file systems like IPFS, for example, for store the contents there, similar as well for the AI training data sets, but as well as storing them on those file distributed services, will also have encoded hash in the blockchain as well. So if you go through the smart contract and the transactions, you again will be able to reproduce the repository, so it won't be lost even if, I don't know, somebody tear down IPFS and it disappears. So the way, I mean, if you are still like puzzled about, so how do you actually encode this type of information, it's like basically every time you publish an article, we'll make a compressed and encoded version, which will be stored in a smart contract list. So it will stay there. It has to be limited to 256 kilobytes. So we have to see, maybe we'll omit some pictures, some other stuff. Maybe only the text content maybe will be stored, but something like that. So that's the initial idea. So the idea is that we use the blockchain as a validation repository, so at any time if there is a loss of information or something else, people can actually restore it, and there'll be, of course, cross-check sums and stuff like that at the final record entered in the blockchain, so that you can see at any point in time, okay, is my version actually validated? If there is mismatch, then we'll have to go back and restore it, which will be a longer process and a bit expensive, but at least there is a way to do that.
Thank you. Okay. I don't see any more questions coming into chat. We do have, just kidding, that I spoke too soon. Okay, so which data sets are you using? What are we going to do? This is multiple questions. What are we going to do about articles behind paywalls? And are we able to extract information from tables and figures from PDFs of research articles? All great, really good questions.
So I would answer the first one and the last one, and I will leave the paywall one to somebody else, because otherwise I'm going to be talking too much. So which data sets are we're using? So at this moment we're using data sets coming from core.ac.uk. So it's a portal for open access articles. So we train all our models on those data sets that they provide. So they provide a data set of about 72 million open access paper abstracts and about 10 million full text articles. So that's what we use for training our machine learning models. When it comes to the knowledge validation engine and the stuff behind paywalls, I think somebody else should answer again, but I will just jump directly to the third one. So are you able to extract information from tables, figures, and PDFs? So I would say not yet, but we are working with 2 universities that are doing things in that area. There is a university in Washington, DC that works with extracting information from graphs and images. And we're working with another university in Dortmund that are working on extracting information from tables and what was the names? I don't know. Yeah, and diagrams, so tables and diagrams. So the idea there is that they are trying to basically make kind of a little caption of the image or graph or diagram of what is displayed, so that we can use it in addition to the textual information. So at this point, we haven't, so they have performed several experiments. I mean, they have published papers as well on that. So at the stage which we are is actually to integrate our NLP algorithms together with them, with theirs, and see if it makes sense basically for the hypothesis extraction that we're doing. I mean, certain experiments are coming along in the next few months, so you'll probably hear about that in the fall, how this went through. So hopefully we'll be able to publish something together with them on that front. So yeah, on the paywalls, yeah, I don't know, Jacob or Maria, do you want to?
So I guess the answer is that we are not going to go down the Sci-Hub route. We are not going to try to break and make explode copyright law. We're going to try to undermine it being totally legal. So it's going to be up to the authors or the right holders to any paper behind a paywall to upload that into our system. We're not going to jailbreak that. And we think we have plenty of, as Victor said, in the data sets that we're using, we have plenty to work with to keep developing the technology with the open access data sets. We started off the project in 2015 with access to, a couple tens of thousands, was it below 20 million, just above or below 20 million open access papers?
A couple of million, yeah.
It's just skyrocketed from 2015 to today. And that's where we're gonna place the emphasis short term in developing the AI algorithms. But like our theory of change contemplates introducing incentives. If this goes where we wanted to take it, there will be, we do not see a world 5 years from now where, the compilers of research journals or the publishing houses are able to charge a fee for an article that has not been put through the knowledge validation engine. Right? It creates a kind of a digital yes or no categorization for classifying documents at that point, because the standard of quality is just going to be the greater if a paper has been submitted and passed successfully the test and the validity report in the knowledge validation engine. So that's kind of our indirect way of trying to put an end to those paywalls in a medium to long term.
Love all these questions. The Q&A is my favorite part of these webinars because I even learn something sometimes. All right, so 2 more minutes. I will absolutely leave the floor open for any more questions coming in. For the 3 on the call, is there anything, I know a lot of you have been attending conferences, talking with researchers and scientists who are interested in Aiur and blockchain and et cetera. Are there any FAQs that you guys have heard in your travels that you feel like we should address in this webinar today?
I think many of the relevant questions already came up, especially the ones related to the data and the paywalls, as well as the technical side of the KVE.
Mm-hmm. Excellent. Excellent. Okay, well, I do not see any more questions coming in, so we will go ahead and wrap up for today. Couple of house cleaning notes. We will be emailing out this recording to anyone who RSVP'd on Eventbrite, and then also posting on Facebook. So if you missed any of it, I know someone was having some internet troubles, so don't worry, this is all recorded. We're going to be putting it up. Please join us for developments on Project Aiur in our community. So you can find us on Facebook, on the iris.ai Facebook page, and also the iris.ai community page. And then we have a Telegram, so it's t.me/theiris.ai, and I'll send those links out as well with the recording. So we would be glad to have you and continue to get feedback. As I hope we've emphasized in this is a community effort and is going to take participation from everyone to really make a success. So we would love to keep in touch with all of you guys who joined us for today. Thank you, Maria, Jacobo, and Victor for presenting. And yeah, keep in touch. We'll be doing more webinars in the very near future. So we hope to see you at the next one.
Bye, guys.
Bye.
Thank you.